So this is the third session of this last module. So yesterday I have explained about Fick's law of mass transfer. It's explained that the mass transfer or mass diffusion is always proportional to the concentration gradient. This is from the mass transfer always occur from or mass diffusion can always occur from a higher concentration region to lower concentration region. Okay, so and that we have discussed about that equation that Na equal to Ma by A equal to minus DAB dCAB dx. Okay, for fixed load. And we have discussed about DAB, that is diffusion coefficient. Diffusion coefficient, and the value negative shows that the diffusion coefficient is from higher region to lower region or opposite direction of the increase in concentration. Okay. So yesterday I have written a particular equation for diffusion coefficient, that is DAB equal to 0.043 into T raised to 3 by 2 in T raised to 3 divided by P of V raised to 1 by 3 plus VB raised to 1 by 3 whole square into root of 1 by MA plus 1 by MB steamed square plus okay, this is the data book. Okay, so that is T equal to absolute temperature and the pressure P equal to total pressure. Total pressure means pressure of air plus pressure of P. That is by Dalton law of partial pressure P equal to PA plus PV, and Ma and Mb is molecular weight, V and B is molecular volume. This is the condition for gas or gas mixtures. Gas or gas mixtures. DAB equation for gas or gas mixtures. So then there are two more equations also for the solids and for liquids. And equation ചെയ്തിട്ട് നമുക്ക് ഒരു പ്രോബ്ലം ചെയ്തിട്ട് നമുക്ക് ഈ സെക്ഷനിൽ വേറെ സെക്ഷനിലേക്ക് പോവാം. Okay. Then for liquid, we can write the equation as there is a different type of equation for liquid. ഇതൊന്നും അധികം ഇങ്ങനെ ചോദിച്ച് കാണാറില്ല കേട്ടോ, ക്വസ്റ്റ്യൻസിലൊന്നും അധികം ചോദിച്ച് കാണാറില്ല ഇതിനൊന്നും. എന്നാൽ നമ്മൾ പഠിക്കാതെ പോയി കഴിഞ്ഞാൽ ഇത് ചിലപ്പോൾ വന്നു കഴിഞ്ഞെങ്കിൽ for liquid there is equation related to dAV, that is dAV equal to 0.001858 to T raised to 3 by 2 all divided by P of sigma AB. P of sigma AB square into home. Home means a researched home. Home into say 1 by MA plus 1 by MB all raised to 1 by 2, that is square of root of that 1 by MA plus 1 by MB. So there is a different term related to sigma AB and ohm. Sigma AB and ohm. Pressure is P is total pressure, T is absolute temperature, Ma and Mb are molecular weights. What is sigma AB and ohm? So sigma AB is the collision diameter. Sigma AB equal to collision diameter. If there is a question related to this particular equation, the sigma AB value and ohm value will be given in your question. Okay, collision diameter is given. This unit of it is Armstrong. It will be given in your problem. Then ohm value is collision integral. Collision integral. It will be also be given in your question. So അത് നേരിട്ടല്ല തരിക, അതിനൊരു ചെറിയൊരു ഇക്വേഷൻ ഉണ്ട്. That is the value of ohm will be compiled by giving a function of kt by sigma AB. kt by sigma AB equal to ohm ആണ്. kt by sigma AB ന്റെ വാല്യൂ തരും, അതിന് കണക്കായിട്ടുള്ള ഓം വാല്യൂ ആണ് എടുക്കേണ്ടത്. ഇതൊരു പ്രോബ്ലം ചെയ്യുന്നുണ്ടെങ്കിൽ മനസ്സിലാവും. അപ്പോൾ ഈ പ്രോബ്ലം ഞങ്ങൾക്ക് PDF ആയിട്ട് തരും. അപ്പോൾ അത് ആ പ്രോബ്ലം സിമ്പിൾ പ്രോബ്ലം ആണ് ചെയ്യുമ്പോൾ മനസ്സിലായത് എങ്ങനെയാണ് അപ്പോൾ ഇക്വേഷൻസ് വരുന്നത്. സിഗ്മ AB എന്ന് പറഞ്ഞാൽ സിഗ്മ A പ്ലസ് സിഗ്മ B by 2 ആണ്. sigma AB equal to sigma A plus sigma B by 2. It will be given in your problem. Sigma A and sigma B value will be given. Sigma A can be found by sigma A plus sigma B by 2. And by finding the ohm value, the equation KT by sigma AB. Equation use it. So there is a value related to the particular KT by sigma AB be given in your problem and can easily find out the value of Ohm value and then substitute the value in the equation and to find out the diffusion coefficient for liquids. Okay. Okay, there is no equation in the case of solids here. There is no equation in the case of solids. As I said yesterday, the diffusion or the properties of diffusion coefficient. The properties of diffusion coefficient was the value of higher for diffusion coefficient, the value of higher is for gas and very lowest for solids. Okay, value of diffusion coefficient is higher for gas and lowest for solids. So which means that the diffusion coefficient is very important in the case of gases or liquids only. It is not very important and that much important in the case of solids. So there is no problem or no theory related to the particular diffusion coefficient of solids. Okay, it's very important or it is relevant that particular diffusion coefficient relevant in the case of gas only, gases or maybe some areas of liquids only. There is no influence or particular relevance in the case of solids. So there is no equation for solids, only liquids and gas we want to study. Okay, so that is the case of particular equations of this DAV in the case of DAP means diffusion coefficient in the case of gases and liquids. So it's a problem നമുക്ക് problem മനസ്സിലാകുന്നുണ്ട്. So please write down a simple problem to apply the particular equation. രണ്ട് question ഉണ്ട്, but first in the case of gases and second in the case of liquid. രണ്ട് problem ഉണ്ട്. ഒന്ന് നമുക്ക് ചെയ്യാം, that is for solids, for gases, for gas. First equation for gas we can do. So please write down a simple problem to apply the particular equation. From the data given below, calculate the diffusion coefficient. Calculate the diffusion coefficient for NH3. For NH3 in air. NH3 particular diffusion of NH3 in air at 27 degrees Celsius. At 27 degrees Celsius temperature and atmospheric pressure, ATM pressure. So you want to find out the diffusion coefficient of NH3 which is diffusing in air at 27 degrees Celsius. Okay. So the given data are NH3. For NH3, that is NH3 is diffusing in air, right? NH3 is diffusing in air. So NH3 can be written as A and air can be written as B. Both particles A and B. DAB എടുക്കുമ്പോൾ first particle is which will diffusing into. So NH3 is taken as particle A and the molecular weight equal to is given as 70 and molecular volume equal to 26.43 centimeter cube per gram mole. Okay. Molecular weight and molecular volume is given in the case of NH3 and air also. And in the case of air also, air is a body B, and also molecular weight is given as 29 and molecular volume is given as 30.6 centimeter cube per gram mole. Okay. Centimeter cube per gram mole. So find out, our equation is there to find out the diffusion coefficient. Given data are MA. As MA means of NH3. MA is given as 17. VA is given. VA is given as 26.43 and unit is write in the particular unit here. MB is given as 29 BB is given as 30.6, right? And temperature is given as 27 degrees Celsius is equal to Kelvin, 300 Kelvin. Pressure is given as 1 atm, atmospheric pressure. Okay, so diffusion coefficient DAB for gases. NH3 is a gas or gaseous mixture. So we can retain the particular diffusion coefficient gaseous mixture. Gas in air. So both are in gas or gas mixture. So we can use the first equation. That is in the case of particular gas and gas mixture, 0.0043 T raised to 3 by 2 divided by P of PA raised to 1 by 3 plus VB raised to 1 by 3 whole square into 1 by MA plus 1 by MB all raised to 1 by 2. That is root of that particular 1 by MA plus 1 by MB. Root of 1 by MA plus 1 by MB. That is root of 1 by 17 plus 1 by 29. Simply substitute the particular values in a particular equation. Simply substitute the particular values in the equation. Substitute the values in the equation. You can find out the value. T is given 300 Kelvin. Pressure is given as 1 atm. 1 atm, you can read 1 or can simply avoid it. VA is given, VB is given, MA is given, MB is given. We can directly find out the value of the diffusion coefficient. Substitute the particular values. You will get 0.0043 into 300 raised to 3 by 2 or divided by 1 into 26.43 raised to 1 by 3 plus 30.6 all raised to 1 by 3 whole square into 1 by 17 plus 1 by 29 all raised to 1 by 2 means square root of that particular equation. The value will be DAB. DAB, the unit of DAB is centimeter square per second. Centimeter square per second. So by calculating, use a calculator to find the value. The value will be 0.183 centimeter square per second. This is a simple way of calculating the diffusion coefficient in the case of gaseous mixture. If it is given, the problem is given in the case of ohm value or sigma by KT value, something like that, we can use second equation, and the all values will be given in a table, like a table in a question, and we can find directly the value of the particular Q DAB value in the case of second liquid mixture. And again, and I will give you the particular problem in as a note. Okay, note. We don't want to waste time for it. So next topic is general mass diffusion equation or steady state diffusion in common geometries like plane membrane, cylindrical structure, and sphere structure. Plane means plane wall condition, cylindrical structure, and sphere condition. There are three equations related to particular diffusion, MA by A, diffusion, MA by A, diffusion flux law, NA equal to MA by A, like according to Fick's law. So you want to find the equation related to that plane wall, cylindrical one, and sphere wall. So the small half-page derivations are there. So I think we can do a simple derivation in the case of plane wall only, and we can write the particular equation in the case of cylindrical and sphere directly. Okay, like one or 5 to 6 step derivations is there in the case of plane wall, and we can directly write the equations of cylindrical and sphere directly by comparing the particular derivation, and I will give you the particular derivation in a notebook as a PDF. Okay, so there is a generalized condition equation. So we are doing the derivation. So we are there is a general diffusion equation. There is a general diffusion equation, and we are taking the general equation in the case of symmetrical plane wall equation of cylindrical wall equation and sphere wall another equation. So we can directly write the equation of general equation. It is not much important. The derivation part is not much important. So I skip the derivation part and writing the equation, that is general mass diffusion equation. General mass diffusion equation. Equation in stationary condition, sort of stationary media. There is a particular derivation. This derivation is not much important, but where we are doing that, so for solids, for plane ball, and for cylindrical and sphere, we are taking a part of this final derivation, this final equation, as a starting of the equation. So this derivation is not much important, but the equation is very important. That is the generalized mass diffusion equation for a stationary condition, for a not moving condition. For stationary condition is dou square Ca by dou x square plus dou square Ca by dou y square plus dou square Ca by dou z square plus Na by dAb plus Na by dAb equal to 1 by dAb into dou into Ca by dou tau. This is the generalized condition equation for a stationary condition. The figure is like this. For this derivation, figure is like this. That is for x, y, z coordinate. For x, y, z coordinate, there is a particular dou z by dou x equation for the three dimensions. So in the case of x direction, y direction, and z direction, so total generalized condition is dou square Ca by dou x square plus dou square Ca by dou x square. That means that the whole the generalized equation is for 3 dimension. It's a 3 dimension equation. And for derivation of plane mode, we are taking only 1 dimension in only case of x direction only. So we are cancelling that particular for y and z also. And we are doing the derivation. അങ്ങനെയാണ് ഞാൻ പറഞ്ഞത്. അപ്പോൾ ഇത്ര വലിയ ഡെറിവേഷൻ. അപ്പോൾ നമ്മൾ ഓരോന്നും എടുക്കുന്നത്. Plus cos A by dou square plus cos A by dou y square plus plus cos A by dou z square plus Na by dAb. Na is the mass flux. That is Ma by A. Equal to 1 by dAb dou Ca by dou tau. Dou means simply a small, for a small infinitesimal area. For a small area, we are taking dou. If it is for higher degree, we are taking d square Ca by dx square. Okay. Ca is the molar function. Okay. So by taking this derivation as a preliminary equation, we want to find the values of the diffusion equation, steady state diffusion through a plane wall. Very important topic here. Steady state equation, steady state diffusion. Steady state diffusion for a plane wall. Simple derivation. പെട്ടെന്ന് മനസ്സിലാവും. Okay, there is no more questions. There is no much confusion. Simple. So consider a plane wall. Consider a plane wall. The figure is like this. Please draw the figure. Consider a plane wall which has a thickness L. Thickness L. That is here x equal to 0 and here x equal to L. Plane wall of thickness L. Okay. Then mass concentrations or molar concentrations. Two phases can be written as here. For this ball, we can take a Ca1, and for this ball, we can Ca2. Final condition and initial condition. Ca1 and Ca2 mass concentration, molar concentration. Ca1 and Ca2. Okay. 3 figure. This is the figure. So here, concentration, you can find diffusion equation that is Ma by A. Ma by A. Ma by A. From that one particular plane wall, through the plane wall. through the paintball MI/A equation ആണ് നമ്മൾ കാണുന്നത്. MI/A, that is for first of all we are taking the value CA1, CA value CA1 and here CA2. ഒറ്റ ബോഡി ഉള്ളത് അതുകൊണ്ടാണ് രണ്ട് വാളാണ്. അപ്പോൾ CA1 and CA2. CA/CB അല്ല, CA1 and CA2. It is the figure. So please consider a mass diffusion of fluid A. Consider a mass diffusion of fluid A. Only a particular body is here. A only on B. A. Consider mass diffusion of fluid A through a plane membrane whose thickness is L. The mass concentration of fluid at opposite faces are CA1 and CA2. The mass concentration of fluid at opposite walls are CA1 and CA2. Thickness is L. So considering diffusion along x-axis only. So considering this particular equation, considering as one dimensional, is right on a very important point. Is considering one dimension. One dimensional ആണ് ഈ x, y, z 0 ആവുന്നത്. Considering as one dimensional, bracketly through x-axis only. Considering as one dimension, that is through x-axis only, we can convert that particular general equation as, we can convert this equation as one dimensional ആകുമ്പോൾ ബാക്കിയൊക്കെ 0 ആവും. 1/dAB dou CA by dou T എന്നുള്ള equation n/A thought it will equal to 0. Only dou square CA by dou x square will be the only term remaining here. This is for whole general equation. For x-axis, y-axis, z-axis വരുമ്പോഴാണ് particular equation വരുന്നത്. RHS വരെയാണ് വരുന്നത്. So if we are taking only one dimensional equation, that is dou square CA by dou x square only, we can write the general equation will be dou square CA by dou x square equal to 0. Dou square CA by dou x square equal to 0. Dou square CA by dou x square equal to 0. Considering one dimensional equation, dou square CA by dou x square equal to 0. By integrating this equation, we will get, what is the integrating term? Dou square CA by dou x square is second derivative one. So integrating about d dou CA by dou x square. Integrating dCA, dou will be di1, dCA by dx, d into CA by dx. ഇത് ഡോ dn എടുത്തോളൂ, d square CA by dx square എടുത്തോളൂ. കാരണം we are taking this as a very infinitely small area. ആണ് എടുക്കുന്നത്. സോ അതുകൊണ്ടാണ് നമ്മൾ ഡോ എടുക്കുന്നത് അല്ലെ. We are taking infinitely small area for analysis. So we are taking dou square CA by dou square also. So here we are taking directly a plane ball. A plane ball is taking here. So we can take d square CA by dx square. ഇങ്ങനെ എഴുതുന്നു, d square CA by dx square. d square CA by dx square is equal to 0. By integrating we will get dCA by dx equal to C1, constant. A constant will be given. dCA by dx equal to C1. And by again integrating, we will get CA equal to dCA by dx. Integrating of dCA by dx will be simply CA itself. CA equal to C1x plus C2. ശരിയല്ലേ? C1x plus C2. Integrating C1 with respect to x, C1x will be the value, and again integration term will become C1x plus C2. Again integrate ചെയ്തുമ്പോൾ കിട്ടും C1x square plus C2x plus C3. So it is the primary first equation. CA equal to C1x plus C2. So then we are finding for C1 and C2. We are providing the particular boundary condition to find the value of C1 and C2. ഇനി C1 ഉം C2 കണ്ടുപിടിക്കുന്നു, ഇതിലേക്ക് ഇട്ട് കൊടുക്കുന്നു, അത്രേ ഉള്ളൂ. Find the value of C1 and C2 and simply substituting the particular value in this equation, you will get the final equation. Okay. So to find C1 and C2 using boundary condition. What is a boundary condition? The only thing you gotta do is d square CA by d square. Integrating, you will get CA equal to C1 plus C2. Double integration. And boundary condition, applying boundary condition. What is a boundary condition? At x equal to 0, at x equal to 0, at x equal to 0, CA equal to CA1. And x equal to L, CA equal to CA2. Right? At x equal to 0, CA equal to CA1, and x equal to L, CA equal to CA2. And x equal to CA equal to CA1, and at x equal to L, CA equal to CA2. Okay. CA equal to CA1 and x equal to CA equal to CA2. So apply the particular boundary condition to find C1 and C2. Apply the boundary condition. First boundary condition we will get, applyable we will get at x equal to 0, CA equal to CA1 now. So first equation applyable, CA1 equal to C2. That x will be 0, x equal to 0. So C1 x that water value will be 0. And we will get CA1, x equal to 0, CA1 equal to C2. Is it clear? Clear or no?
Yes, sir.
Okay. Apply first one condition, x equal to 0, CA equal to C0. So C2 value already. Then apply second boundary condition. That is x equal to L, C1 allowed, x equal to L, CA equal to CA2. That is CA2 equal to C1L plus C2. C1L plus C2. So from this condition, find the value of C1. C1 I would say. C1 I would say CA2 minus C2. CA2 minus C2 divided by L. C1. CA2 minus C2 divided by L equal to C1. So C2 equal to CA1. C2 equal to CA1. So C1 will be CA2 minus CA1 divided by L. CA2 minus C2 divided by L. CA2 minus CA1 divided by L. C2 minus CA2. So C1 will be CA2 minus CA1 divided by L. And C2 equal to CA1. This is a boundary condition, C1 and C2. C1 and C2. So substitute in equation 1. Substitute in equation 1. Substitute in 1. We will get CA equal to, we will get CA equal to C1x plus C2. C1 is CA2 minus CA1 divided by L into x plus C2. C2 is C1. Okay. This is equation for CA. So equation 2. Equation 2. Okay. Then we know we want to find the value of MA by A on a MA by A. So in the by equation by Fick's law, we know that MA by A equal to minus DAB. Minus DAB. So in this condition, not AB illa. Only simple D DA anything. So D into dCA by dx. dCA by this condition. By Fick's law, in this particular condition, MA equal to minus D into dCA by dx. Okay. Then substitute the value for CA here. Substitute the equation for CA here. You will get the final equation. Substitute the equation for by Fick's law. We know that MA by A equal to minus DAB dCA by dx. This condition, DAB is not there. Like this body B is not there. Only A is there. So simply we can write DA or D itself. MA by A equal to minus D into dCA by dx. Substitute for CA. That is minus D into d by dx of that whole equation. That is CA2 minus CA1 into x by L plus CA1. Okay. So find the derivative of this particular value. That is Derivative എന്താണ്? 2 derivative ആണ്. d by dx of this value plus d by dx of this value. So d by dx of this by second value CA1 is a constant value. That is d by dx of CA1. X ന്റെ വാല്യൂ ഇവിടെ ഇല്ല. So that particular value is 0. Second term will be 0. ഫസ്റ്റിൽ എന്താണ് വരിക? d by dx of this particular value is CA2 minus CA1 divided by L എന്നാണ്, കോൺസ്റ്റന്റ് ആണ്. ചെയ്യാം, നോക്കിക്കോളൂ. Minus d into d by dx of first equation, that is CA2 minus CA1 divided into L by x ആണ്. Into L by x plus d by dx of CA1 ഉള്ളിലേക്ക് കൊടുത്താൽ, so d by dx of CA1 will be 0. That is constant value ആണ്, x value ഇല്ല, 0. Second condition ആണെങ്കിൽ into x by L ആണ്, into x by L. Condition ആണെങ്കിൽ CA2 minus CA1 divided by L is taken outside, constant value, and d by dx of x is there. d by dx of x is 1. So the equation will be, the derivative will be this value. So total equation will become ma by a equal to minus d into CA2 minus CA1 divided by L. Okay. CA2 minus CA1 divided by L. So if I cancel negative value cancel ചെയ്യാണെങ്കിൽ we can write CA1 divided by CA2. Just change the particular values to find negative value കളയണമെങ്കിൽ divided by L. This is our final equation. ma by a equal to CA2 minus CA1 divided by L. So otherwise we can write this equation as CA1 divided by CA2 divided by L by D. D അടിയിലേക്ക് കൊണ്ടുപോയി L by D എന്ന് കിട്ടും. This is the final equation for the plane wall. Final equation for steady state diffusion equation or steady state diffusion for a plane wall will be ma by a or Na. Total Na equal to ma by a equal to CA1 divided minus CA2 divided by L by D. And this L by D is known as diffusion resistance. Okay. This is the mass flux. This equation is the mass flux through plane wall. This is equation for a mass flux through plane wall. ma by a equal to CA1 minus CA2 divided by L by D. L is the thickness, D is the diffusion coefficient. D is not diameter. D here diameter illa, plane wall ആണ്. So CA1 minus CA2 mass concentrations and L by D equal to L thickness divided by diffusion coefficient, and thickness divided by diffusion coefficient is known as diffusion resistance. So in every, for cylinder also, for sphere also, we will get a particular equation like this, that is CA1 minus CA2 divided by any particular denominator term, and that particular denominator term will be a resistance. Diffusion resistance for a plane wall, diffusion resistance for a cylinder, diffusion resistance for a sphere. That is only our derivation. So here ma by a equal to CA1 minus CA2 divided by L by D is the mass flow equation for a plane wall. Okay. So we can continue for a cylindrical and sphere. The equation, we can write equations and we can do a simple problem related to sphere and cylinder in our next class. Please go through the data book thoroughly and you will find the particular equations there itself, including figures.